Alright, in this video we will be completing and balancing equations. I know you've had experience balancing equations, but now we're going to expand on that, and given the reactants, I will ask you to complete the reactions. If you recall, there are 5 types of reactions that we discussed. There's combination, decomposition, single displacement, double displacement, and combustion. So given these the reactants for each of these reactions, you will be asked to complete and then balance the reactions. You will be told when a combination reaction is taking place or a combustion reaction is taking place, so there's no guesswork there, but you will have to determine what the products are. So the first one we'll talk about is combustion, because I think that's the easiest. If you recall, in a combustion reaction, we take a carbon source, in this example methane or natural gas, CH4, you combine it with oxygen. See, these are the reactants. And in a combustion reaction, the products are always going to be what? Carbon dioxide and water. So easy enough to complete the reaction, but we're not done there. We still have to balance it. So if you notice now, there are 4 hydrogens in the reactants, only 2 in the products. So it's not balanced. So we balance the reaction by applying coefficients, and to remind us that we only change the coefficients at this point, I'll put a red line in front of each substance. Once balanced, you'll see we have a coefficient of 2 here, so 2 times, well, let's back up. So in order to balance the hydrogens, right, we had 4 hydrogens in the reactants, only 2 in the products, we needed a coefficient of 2. This 2 also applied to the oxygens, so now we have 2 plus 2 is 4 oxygens, so we need a 2 here in front of the oxygen in the reactants. So now it is balanced. The next reaction, single displacement. If you remember, this is Do You Mind If I Dance With Your Date reaction, where the big guy here cuts in. So we in a single displacement reaction, we have one element displacing another, so this guy is kicked out, and this element here, this big guy here, is dancing with the lady, and this guy is left by his lonesome. In general form, an element A displaces element B, so AC is now our new compound, and element B is kicked out. A specific example of this would be zinc. This is elemental zinc is a solid, reacts with copper sulfate. This would be copper sulfate in a solution. The zinc comes in, displaces the copper, right? So what would the products be? All right, so zinc is now dancing with sulfate, and copper is left by his lonesome. Whenever you complete these reactions, there's a couple questions you need to ask yourself. First, are the charges balanced? Hopefully you remember that zinc is always a +2 ion. The sulfate polyatomic ion is always -2. So these charges are balanced. The charge in the copper, well, this is elemental copper. If you remember, all single displacement reactions are redox reactions. So a free uncombined element like zinc or copper has an oxidation state of 0. But when zinc forms a compound, as it does here with zinc sulfate, it's going to be a +2 ion. The next question is the reaction balanced? 1 zinc, 1 zinc, 1 copper, 1 copper, 1 sulfate, 1 sulfate. Yeah, it is balanced, but remember, when you go to balance equations, put a line in front of each substance here. You're only going to be changing the coefficients. You do not change the subscripts. This is an example of a metal displacement reaction. One metal displaces another. Right? So the zinc displaces the copper. There are a couple other different types of reactions. We'll look at single displacement reactions where it's not a metal displacing another metal. In this reaction, we have magnesium reacting with water. So what are the products? In this case, a metal replaces or displaces hydrogen. So if you recall, metals form cations. Now this is elemental magnesium, so the oxidation state is 0. But when magnesium does form an ion, it's a plus or a positive ion, It's a cation. It's going to displace the hydrogen because the hydrogen likewise forms a positive ion. So the magnesium displaces the hydrogen. So what would the products be? Magnesium combined with oxygen, and hydrogen now is the element left by its lonesome. Remember that this 2 here isn't used to balance the equation. The 2 here is because hydrogen is one of the 7 diatomic elements. So be careful of these when we displace the hydrogen, and it's not just H, it's H2. Now is this equation balanced? Put in the lines, 1 magnesium, 2 hydrogens, good. 1 oxygen, yes, it's balanced. Another reaction, instead of magnesium reacting with water, we could have a metal reacting with an acid. This again would be a displacement of hydrogen. So what would the products be? Right, the zinc displaces the hydrogen, so we get zinc chloride and hydrogen. Caution. Again, what are the subscripts? Hydrogen isn't just H, it's H2. It's a diatomic element. Zinc chloride isn't ZnCl, it's ZnCl2 because zinc always forms a +2 ion. Chloride's -1, so we need 2 of them, 2 chlorides, to balance the charge on the zinc. Right? So we use subscripts to get the correct chemical formulas. Now we can go through and find out if it's balanced. We'll put the lines in. We have 1 zinc, that's good. Hydrogen, there's 1 hydrogen here, but there's 2 here. Uh-oh, not balanced. 1 chlorine, 2 chlorines in the products, not balanced. So we'll need to put a 2 here in front of the hydrogen. Right? So now we have 2 hydrogens in the products, 2 HCl molecules, so 2 hydrogens in the reactants. This 2 also applies to the chlorine. That's good because now we have the chlorines balanced. So this equation is balanced with just the 2 in front of the HCl. The previous examples were with metals. Here we have a nonmetal, fluorine, elemental fluorine, again a diatomic element. What would the products be? Well, here a nonmetal is going to replace another nonmetal. So fluorine is going to replace which one? It's going to displace the chlorine, right? Not the sodium, but the chlorine. So what would the products be? Sodium is now combined with fluorine, and chlorine's by its lonesome. Next, make sure you have the correct subscripts. Sodium is +1, fluoride's -1. Good, those charges balance. But chlorine here is one of the 7 diatomic elements. So you have to check for these tricky diatomic elements. Make sure it's not just Cl, but Cl2. Once you have the correct subscripts, now you can go through and ask if the equation is balanced. So remember we use coefficients to balance the atoms. We use subscripts to balance charges. So here we have 2 fluorines. There's only 1 here. So we're going to need a 2 in front of the sodium fluoride. This gives us 2 sodiums, right? There's only 1 here, so we're going to need a 2 here. This also applies to the chlorine, so that's good. We have 2 chlorines in the reactants, 2 chlorines in the products. The next reaction, double displacement. This is probably the most complicated, hardest type of reaction you'll be dealing with. If you remember, this reaction is when the reactants switch partners. So here the guy in the yellow shirt is dancing with the lady in the orange shirt. Then they just switch partners. He's dancing with the lady in the white shirt. In a generic form, A is dancing with B, so we have compound AB, compound CD. The A and C switch places. A is now dancing in the products. A is dancing with D, and C combines with B. So the steps to completing double displacement reactions, and remember, we will tell you that it is a double displacement reaction. The first thing you have to do is switch the cations. Remember, the cation always, these are going to be ionic compounds, and the cation is always the first part of the front part of the chemical formula. So again, A and C switch places. Given a specific example, we have calcium chloride in solution, silver nitrate in solution. We're going to switch the cations, right? Calcium is plus, chloride is minus, so calcium is the metal, it's the cation. Silver is the metal, it's the cation. We're going to switch places. What are the products going to be? We'll get calcium now combined with nitrate and silver combined with chloride. Okay. That's the first step, switch the cations. Second step, balance the charges by using subscripts. The question you're asking yourself here is, what is the chemical formula formed between calcium ions and nitrate ions? Well, calcium is in group 2 in the periodic table, so it's plus 2. Nitrate is minus 1. These charges are not balanced. Silver is plus 1, chloride's minus 1, so the charges here are balanced. But calcium nitrate, no. So what do we need to do? Right, we're going to need 2 nitrates, each with a minus 1 charge, to balance the plus 2 charge on the calcium. Alright, now once you have the charges balanced, this is different from any of the other reactions we're going to talk about. I'm going to ask you to check a solubility table. And there's a solubility table in your lab manual. It'd be very useful to have this when you're doing the test in this unit. I will talk more about the solubility table in a little bit, but essentially what we need to do is we need to figure out what the physical state of the products are going to be. These two are aqueous, or dissolved in water, right? So we have 2 solutions, we mix them together. What are the products going to be? So you check the solubility table and you find out that calcium nitrate is soluble, so it's aqueous, it's dissolved in water. You check the solubility table, but silver chloride is insoluble, it's a solid. So the tricky part here is to remember that aqueous, AQ, right, means it's soluble. So you look on the periodic table, calcium nitrate is soluble, we write AQ. We don't write S. S means solid. This is the physical state. In the solubility table, you check silver chloride, it'll say it's insoluble, so we write solid. It forms a precipitate. Right, so now we've determined the physical states of the products. The last step is to balance by inspection. Here we're using coefficients to balance the atoms. Calcium chloride, we have 1 calcium, that's good. Chlorine, we have 2 chlorines, only 1, so this is not balanced. We're going to need to apply our coefficients. Right. We have 2 nitrates, right? We use the 2 to balance, remember, to balance the charges. We use the subscript of 2 to balance the charges. So now we have 2 nitrates. We're going to need a 2 in front of the silver nitrate in the reactants. This also applies to the silver. So we're going to need a 2 here in front of the silver in the products. This 2 also applies to the chlorine. That's good because there are 2 chlorines. So now this equation is balanced. Solubility table, as I was saying, we had, what did we have? We had calcium nitrate and silver chloride in the products. So we look here, calcium, okay, and you go along here to find the nitrate polyatomic ion, calcium nitrate, right? It's soluble, so we write AQ. Okay. Silver, right? We find the chloride ion. Here's the chloride ion. The silver ion, insoluble. Silver chloride is insoluble, so we write S for solid. More practice with double displacement reactions. First thing we do is we switch the cations. Right? So switch out the metals. We have sodium phosphate, calcium nitrate. What are the products going to be? Calcium displaces, or sodium displaces calcium, so sodium is now combined with nitrate. Calcium is combined with phosphate. The next question you ask is, what subscripts do I need? I need to balance the charges. Calcium is +2, phosphate is -3. Those charges are not balanced. Right? So we're going to need 3 calciums and 2 phosphates. Remember, that was a crossover business. Calcium is +2 charge. You can bring that +2 charge down here. Phosphated polyatomic ion is always -3. Bring that -3 charge down here. You get the correct subscripts. By the way, the subscripts in the reactants should be correct already. You don't have to mess with those. It's just in the products. Sodium is +1, nitrate's -1, so they're already balanced. What's the next step? You check the solubility table. Here you'll find that sodium nitrate is soluble, so we'll write AQ. Calcium phosphate is insoluble, right? So we write S for solid. So remember, in the solubility table, you look up calcium phosphate, it says it's insoluble, we write S for solid. Sodium nitrate is soluble, for that we write AQ. What's the last step? We balance by inspection. So we'll put lines in front of each substance. If you notice, we put the 3 here to balance the charges for calcium phosphate, but now we have 3 calciums in the products and only 1 in the reactants. So we'll need a 3 here. This 3 also applies to the nitrates. So there's 2 nitrates in calcium nitrate, coefficient of 3. 3 times 2 is 6. We have 6 nitrates now in the reactants. So we need 6 nitrates in the products. Okay. That 6 also applies to the sodium. So in the reactants we have 3 sodiums. In the products we have 6. So we're going to put a coefficient of 2, right? That 2 also applies to the phosphate, and that's good because if you look in the calcium phosphate, we do have 2 phosphates. So now this equation is balanced. The next reaction we'll do are combination reactions. If you remember combination reaction in general form, we have 2 reactants, they give us 1 product. There's a variety of different types of combination reactions, but essentially the question you need to ask yourself here in this example, we have sodium and chlorine. What is the formula of the compound formed between sodium and chlorine? Simple enough, NaCl. Is this equation complete? Yes, but is it balanced? No. Right? We have 2 chlorines in the reactants, only 1 in the product. So we're going to need to put a coefficient of 2, but that 2 also applies to the sodiums. So we're going to need another coefficient in the reactants, and now the equation is complete and balanced. Next reaction here, this is the reaction between carbon dioxide and water. This one's a little bit easier. Right? If you dissolve carbon dioxide with water, it will react. And remember, you get 2 reactants combined to form 1 product. This product is carbonic acid, H2CO3. The next reaction is decomposition. If you recall, decomposition is just the reverse or the opposite of combination. So in the last slide we had combination, A and B combined to form 1 compound AB. Here's just the reverse. A and B are together in a compound and then they separate. So we'll look at a couple different decomposition reactions. There's a number of different types of decomposition reactions, but the one I'm going to focus on here is the ionization or dissolving reaction. So this is what happens when we put, say, sodium chloride into water. We'll put water on the reaction arrow. This means we're just dissolving sodium chloride. What do you get? Well, you get sodium ions and chloride ions. Okay, so it dissociates or ionizes, and we get the ions in solution. Another example here, calcium and phosphate. Good thing to remember here, is your polyatomic ions. You need to be able to break these compounds up into the cation and the anion. So think about splitting it right here between the cation and the anion. We're going to get calcium ions and phosphate ions. Okay, but we need to include the charges, so don't forget the charges. What's the charge on these guys? Calcium is in group 2, it's +2. Phosphate is always -3. Alright, so we completed this reaction. And is it balanced? No. If you look in the reactants, we have 3 calciums, but only 1 in the product. So remember, when we balance these, we put in coefficients. We don't use subscripts to balance atoms. So we need 3 calciums in the products. How many phosphate? 2 phosphate. And that's all I have to say about that.